Newton's laws. All right, question number 5. A 5 kilogram mass and a 20 kilogram mass are connected by a light inextensible string which passes over a light frictionless pulley. Initially, the 5 kilogram mass, this 5 kilogram mass, it's held stationary, meaning it's not moving, on a horizontal surface, while the 20 kilogram mass hangs vertically downwards, 6 meters above the ground. So that means before any motions, this 20 kilogram, it's 6 meters above the ground, but the moment it begins to fall down, the distance will now be shortened. As shown in the diagram below, the diagram is not drawn to scale. Thank you very much. When the stationary 5 kilogram block mass, this one, is released, the two masses begin to move. The coefficient of kinetic friction, which is between the 5 kilogram mass and the horizontal surface, is 0.4. Ignore the effect of air friction. All right. Good. So they say calculate the acceleration, blah, blah. So the scenario is we are, but okay, now the moment these things begins to move, this one was 6 meters above the ground. So since we already know there's friction here, so we're like, okay, friction. There's friction here because we can tell this thing is going to move towards the right, and this one is going to move downwards. Everybody agrees with that one. So this one I'm going to put it there. So now there is a tension on that string that's pulling, and there is a tension on this one upwards, and then on this one here there is a force of gravity pulling down. Again, it is mg, 20 times 9.8. Do it. 196 newtons. And then coming here, you also have the downward force, which is the force of gravity, which is given by 5 times by 9.8. Do it. You should get a 49 newton. And upwards, you've got the normal force. There we go. So these are all the forces we have here. All right, now we can figure out friction, because I already told you to determine friction, you use Fan. It's mu and normal force. The mu, we already got it. It's given to us as 0.4. So you got 0.4. And then when we focus on the 5 kg, we've got vertical forces, the normal and the 49. So normal will be equal to 49, because it must balance that 49. So 0.4 times 49 will give us the frictional force, which is 19.6. 19.6 newton. So we have a force here, which is 19.6 newton. All right, so everything is well with us here. So now we are able to do all those Newton's laws, whatever. Because it's falling, I know we're going to include free falling bodies, or we can even use energy. We'll do it, don't worry. Now, using the 5 kilogram block, forces that are pointing to the right minus the one pointing to the left, T minus 19.6. So that will be equation 1. T minus 19.6 equals to the M. The M is 5, MA, which is 5A. Of course, the mathematicians will call that equation 1. And then we do the same thing with this one. Downward force, 196 minus the T. All right, so we have 196 minus the T equals to the M. which is 20, and then times by the A. The mathematician will call that equation number 2. I'm going to work from number 1 to solve for t. So I'll say t from the white one is going to be 19.6 plus the 5a. Mathematician would call this equation number 3, which is nothing else but equation 1. Take all of that, substitute it there, but put that in a bracket because the minus will change the sign of 19.6, will change the sign of the 5a. So I'm going to do it already changed. The sign already changed. So it's 196 minus 19,6 minus the 5a, and then the rest of the story will be equals to 20a. So I'm going to bring the 5 there. It's going to be 25. You work out these numbers. Do it. 176.4 equals to 25a. Divide by 25 on both sides to get yourself an acceleration. So the acceleration becomes 7 point. I'm going to put all the numbers 0.56 Newton. I'm not going to wait for them to ask me for the acceleration, for the tension rather. I'm going to substitute it there. So I'm also going to say tension equals to 19.6 plus, open the parentheses, I substitute 7,056, close the parentheses, then I'm going to punch that. It says 19,6 plus 5 times 7.056. According to me, I'm getting 54 point something. So the tension equals to, I'm getting 54.88 newtons. All right, for those who are worried about this one here, if you wanted 2 decimal place, it would be 7.06 meters. It's not a newton. Thanks for going back to that one because it's an acceleration. It's meters per second squared. All right, let's check what they want, these guys. They say calculate the acceleration of the 20 kg. We found it is for, this acceleration is for both the blocks. All right, and then they say calculate the speed of the 20 kg mass as it strikes the ground. Now we change the scenario. We only focus on this guy. We're like, okay, fine. This is the scenario. You have a block here which is actually 6 meters above the ground. So this is 6 meters, which is your delta y. And then at that moment, initial velocity was 0, and then you had the gravitational acceleration, which is 9.8 meters per second squared. It's also downwards. Now what do they want? They want the velocity as it strikes the ground. So now we look for equation of motion that will work, the one that does not include time, because we haven't worked out the time. So if we go for V final squared equals to V initial squared plus 2g delta y, it's going to work beautifully because initial velocity in our case, it will be 0 squared plus 2 times the gravitational acceleration 9.8, and then multiply by the 6, and then at the end I'm writing V final. You understand? I'm not writing V squared. This number here, I'll have to take a square root. The answer after, I'm saying after taking a square root, is 10.84 meters per second. I hope it makes sense to you. If you didn't check the square root, you're going to have a 1,275,295,956. So this is the velocity downwards if you didn't take a square. All right, now the next question, which is this one, 5.1.3. At what minimum distance from the pulley would the 5 kg mass be placed initially so that the 520 kg must strike the ground? All right. Now watch now what it says. It says at what minimum distance from the pulley. So we want the distance from here moving to the left. All right. So that this object, so that this one will just hit the ground. Okay, so we're talking about the minimum distance. So what are they saying to us? They're saying, listen, this object, it's here. If it's here, it will travel downwards 6 meters. Therefore, this one will travel forward 6 meters. So therefore, the distance from the pulley to where the object is, it has to be 6 meters or more. Because if it's less than 4 meters, by the time this thing hits the ground, this one would have gone over the pulley and flying in the air, coming down. So if this one hits down at 6, this one is pushed, or pulled forward 6 meters forward. So we need 6 meters, a minimum of 6 meters. So make it 6, 7, 8, 9, 10, because they say minimum and it's 1 mark. This question is done.